Today's topic is greedy approach. What is greedy approach? Basically, it is a problem solving strategy where at each step we make the choice that looks best at that moment. Okay, so let's say we need to find the maximum. We are having 1, 2, 3, 4. So we will take maximum at each time, right? We will start with 1. At the next step we found 2. This is best, right? We will take 2. At the next step, this is best, we take this one. So this is the greedy approach. That it's leads to the global optimal solution, right? Instead of considering all possible solutions like in DP or backtracking, greedy algorithm make locally optimal choices in step-by-step manner, right? So what are the characters of this greedy approach? So local optimization, greedy choices chooses the best option at each step. Okay, no backtracking. Once decision is made, it's never changed, right? Fast execution, usually more efficient. N log n or maybe on doesn't always work. Now it doesn't always work. Like there are some questions which will be solved using DP. We can't solve using greedy. I will tell you with an example at the last. Okay, so what are the conditions? Condition for applying this greedy approach. So what is the property? We can make a local optimal choice. And it leads to a globally optimal solution. Okay, we will check the question. And optimal substructure, a problem has optimal substructure if its solution can be constructed from the solution of its sub solutions. With the question you will understand, right? So real life example, activity selection problem. You are given an activities with their start time, end time. Select the maximum number of activities that doesn't overlap. So sort by the end time and always pick the next activity with the earliest finish time. This is one of the greedy approach, right? We are given the start time, let's say 1, and 2 is the end time. Here 1 and 3 is the end time, 2 and 4, like this. Now we need to select the maximum number of activities that doesn't overlap. We will sort them by the end time, that is 2 first. This is the sorted order only, right? Now we will always pick the next activity with the earliest finish time, right? So that doesn't overlap. Basically we have done one question, right? Meeting, we need to check the meeting timings, right? This is the same question. We will check the last time with the front time. If they doesn't overlap, we will consider them in the result. Okay, this is the greedy approach. Now what are the steps? First, understand the problem structure, right? This is important. We need to understand the structure, like what is asked in the question and what we need to find. Define the objective function, make a greedy choice, best current option, right? We need to make a greedy choice. After that, reduce the problem, repeat until a solution is built, right? When to use? When you want a quick solution, when you these are nothing. Okay, let's move to the question. So the question is jump game. You are given an integer array nums. You are initially positioned at array's first index, right? Now each element in the array represent your maximum jump length at that position. Return true if you can reach the last index, otherwise false. Okay, let's copy the example. Okay, this is the question. Now this array represent the maximum jump. It's given 2, 3, 1, 1 and 4. Maximum jump from that index, right? F 0, 1, 2, 3, 4. If we are at this index, it can jump 3 more steps, that is 1, 2 and 3 at the last, right? So we are given this array. We need to find if we can reach to the end or not, right? So let's start with the first index. It can jump 2. It can jump either to this index or this index, right? Let's say we have jumped to this index 3. Now from 3 it can jump to the last, right? So we can say yes, true, we can reach to the last index. Now how can we do this? What we are doing, we are choosing the maximum possible jump at each time, right? Choose maximum jump at each index, right? So we are making a greedy choice, right? We are making the greedy choice. So let's say we started with the 2. We have 2 options, right? We started with the 2. Now we are at next pointer. We will check all the pointers within this 2 range. 1 this, 1 this. We are at this. Now this is higher, right? This is the greater jump. We will choose this. Next we will be checking these also, 1 1 and last one. Okay, understood. So let's say we are having the values 1 2 3, or let's say 10 here, then 1, then 2, then 3. Okay, this is the value. What is the index? 0 1 2 3 4 5 6. Now the question is, can we reach to the last index? Okay, and we will be starting from this index 0, right? So the formula we will be using jump I plus I, and we will be taking the maximum of this greedy, right? Max of this at each index, right? Let's say we started with the 0. What is the jump I plus I, right? So what is the jump? It's 1 plus index 0, we will get 1. So with the first we can reach only to this one, Okay, now we are at this index, right? So 1 index, where we can reach, the jump is 2, the index is 1, we can reach to the third index. That means we can reach till here. Okay, now we are at 3. Okay, let's say here values is, instead of 3 and 10 we are having 0 and 0. Okay, so from this second index, where we can reach, 0 jump is there, plus 2, we can reach to the 2 index only, right? The maximum value till now is 3, and when we are at 3, 0 plus 3, we can reach to the 3. Now the maximum value is 3, we can't go after this, right? We can't go after this because the maximum value, the maximum index we can reach is 3. So we are at 3 index, we can't go further, so we can say false. Got it? We can say false. Understood this point? We will be having some condition, right? We will be checking if our index is within max jump, right? This is max jumps, we can reach to the maximum third index. We are doing what? Max jump. For each element we will be calculating max jump, max of max jump and jump I plus I. That means this was the last max jump, right? Max jump, and this is the current max jump. We will be taking the maximum of both, current max jump. For each element we will be calculating this max jump, and when we are getting the maximum we should take that. Okay, so let's say what are the values here. We are having the values 3 and 10, right? So let's calculate again. Here the value was 3. Now for the second index, again we need to calculate what is the value here. It's 3 plus 2, right? We got the 5, means we can reach to the maximum 5, right? Till here we can go now. After that, for third index we are having maximum jump 10 plus what? plus the index, that is 3. We got 13. That means 13 will be somewhat here. That means we will be having the condition, right? We will be checking if max jump is greater than equal to the last index. That means we can reach the last index, right? We can reach the last index. We will say return true. Correct. At this point we can return true. At each index we will be taking the maximum value, the maximum jump, and that is greedy approach. So what we are doing here, let's write the step. So first step will be what? We will be starting with having the max jump, right? Second thing is iterating the loop will be there, right? And what else? And calculating this formula, right? Max jump equal to, checking this formula, max jump equal to maximum of max jump, and the second was the formula, that is jump I plus I, right? Understood? So that's it. Okay, and we will be having some conditions. Let's say if any point max jump is smaller than I, that means we can't reach this I, correct? Max jump is smaller, the maximum index we can reach is smaller than the I, so we will return false here. Return false, correct? And this is for false. And for true, what was the condition? If max jump is greater than equal to the last index, return true. That's it. Shall we code it? So let's code it. So let's say we are having the max jump pointer for the max jump or the last index possible, correct? After that, start the for loop, int I equal to 0, I less than nums.length and I plus plus. After that, we will simply check the false condition, right? If max jump is smaller than I, that means we can't reach I, return false. Can't reach ith index. After that, we will be calculating this max jump equal to math dot max, or what is the math dot max jump, and this nums of I plus I, correct? And at the last, we will be checking the condition for this true. If max jump greater than equal to what? Equal to nums dot length minus 1, return true. That's it. Okay, means reached the last index, correct? And after that, anything we can return, let's say return true, as we need to return something, right? Let's run this. Wrong answer for this one. Why? -1 return true. From 3 to expected false. Why false? Okay, I'm doing 1. Okay, it's accepted now. Understood, right? What is the time complexity here? Simple for loop is there, so the time complexity will be on, as this for loop is there. Simple, right? let's move to the next question. The similar one, jump game 2. So you are given a 0 indexed array, basically same thing as we are given with the jump game. What we need to do? We need to return the minimum number of jumps to reach the last index. Okay, the test cases are generated such that you can reach the last index. Great. So now we need to calculate the number of jumps. So given arrays 2, 3, 1, and 4, right? We need to find the minimum number of jumps to reach the last index. What is the minimum number of jump? In last question, what was it? We can jump from 2 to this place or to this place, right? Maximum 2 jump. So we can either jump to 3, either jump to 1, right? And from 3 we can reach to the last index. So minimum is 2, right? From 2 to 3, 2 to 3, and 3 to 4, right? So we need to find this minimum number of jumps. How can we do? We know that we need to keep two things. One is max jump, right? That means the last index it can reach, correct. And what next? We need to maintain the window, or we can say jump window, the current, or one window or jump, right? Great. So now let's say I have started from this first element, that is 0 index, right? 0, 1, 2, 3, 4. Okay, now I will start from this. The max jump is what? The max jump will be 2. Now I am having one more variable, let's say end. That will be the end of this current jump. That will be max jump only, that is 2, right? This is the end of the current jump. Okay, now I'm saying what I'm saying. This is 2. Okay, this is the end of one jump, right? The first jump, correct. So let's start. We started with this, so it can go till this point. Now when we will come to this second, that is the first index element, we can say now the max jump will be 3, right? Will be 3, but we will be not updating this one. When we will update this? When we will come to this point, we will say our first jump is done. Now we will increment this. Okay, so let's have one more variable, that is answer. Okay, so initially it will be 1. Okay, when this end will complete, we will increment this. Now end is max jump, that is what? 3, and we will increment this answer plus. Great. So it will be 2 now. So after 3 we will be going on, and we will check if we reach the last index. That means this is the answer. Okay, this will be the answer. We will return this one. Great. Now this will be the end of second jump, right? Understood, right? How we are incrementing the answer. Basically this will be the answer, right? When we are completing one end, we will be incrementing our answer. That means we have completed one jump. Now we will put the value of this end as the max jump. That means now we can move to the max jump. The last index will be the max jump. So shall we code it? The max jump logic will be same. After that few conditions will be there, right? For true the condition will be same. If max jump is greater than equal to n-1, return return answer, right? And what is the condition for this end? If is I equal to end, that means we have reached the last point, last index of the current jump. Now we need to take the next jump. So we will increase the answer plus, and what else? We need to modify this with the current jump, with the current maximum index, that is max jump. Got it? These two conditions, just it. So let's code it down. So let's check the n first, equal to nums dot length. Great. After that we will be having jump, max jump. Initially it will be 0, one end pointer, that will be 0, one answer, right, for storing the number of jumps. Great. So let me write it. For end will be the end point or index of current jump, right, and answer is the number of jumps, right. Then we will start with the for loop. I equal to 0, I less than n, I plus plus. Then what else? Now we will be checking the condition. First let's calculate this max jump. Max jump equal to math dot max of what? Max jump. And what's next? The formula, that is nums of I plus I. Great. The same formula we used earlier. Now we will be checking this. If max jump is greater than or equal to n minus 1, that means we have reached the last index. Now we need to return the answer, but initially answer is 1, right? We have taken one jump, so we need to increment it, ans plus plus, right? And if now for the that window, right, if end is equal to I, or I equal to end, that means this is the end of the current jump. We need to increment our answer, right? And what else? We need to modify this end equal to max jump, the current end point, current end index we can reach. This is end of current jump, right? So increase number of jump and modify this value, right? At the end return what? ans. Let's run this again. I am adding 1. I don't know why I am adding 1. Accepted. Okay, let's move to the next question. The question is gas station. There are n gas stations along a circular route, okay, where amount of gas at the ith station is gas of I. Okay, you have a car with an unlimited gas tank. It cost I of gas travel from the ith station to its next I plus 1 station. You begin with the journey with an empty tank at one of the station, given 2 integer gas and cost integer array basically. Return the starting gas station index if you can travel around the circular once in clockwise direction, otherwise return -1. Okay, if there is a solution, it is guaranteed to be unique, right? So what it means? It means there will be only one starting point. Okay, let's copy the example. Okay, so we are given this gas that is equal to 1, 2, 3, 4 and 5. That means we are having this much of gas at which station? 0 index. It will, for 0 gas station it will be having 1, for 1 it will be having 2, for 2, 3, 4, like this, right? And one coast array 4, 5, 1, 2. What is this coast array? This means we will be needing 3 gas to move further, to move to the next station. So if you see, we are having 1 at at station 0, but we need 3, so we can't move further, right? If we check with 1 and here we need 4, again we can't move further, right? Because we need 4 gas and we are only having 2 gas. If we are starting with second index, second station, then what else? What is the situation? We can move to the next? No, we can't, because required us 5 gas, but we are only having 3. If we are at this 3 gas station, then we can start or not? Yes, we can start. See, we only required 1 gas. The cost is 1, but we are having 4, right? So we can start from, let's say, start from third index station, right? Station. What is the gas now? What is the remaining gas after proceeding? It will be 4 minus 1, right? It will be 3. After going to the next, that means after proceeding to the next station, we will be having 3 plus 5, right? That is 8, right? At 4 station, the gas is what? 8, and the cost is 2. So the remaining will be what? 8 minus 2, that is 6, right? So this is circular, right? This is circular. After this station, we will go to at 0 station. The gas will be what? 6 plus 6 is the remaining from the last, plus 1, that is 7, right? We are having 7 gas. What is the cost? Cost is what? 3. So the remaining is 4, right? At 1 station, we are having gas. How much gas? 4 plus 2, that is 6. Cost is what? 2, not 2, 4, right? So remaining will be 2. At second station, gas will be what? 3 plus 2, the remaining, that is 5. What is the cost? Cost is 5. So the remaining will be 0. And we reach the same index, right? We are at this, the gas was 5 and the cost is 5, so we can reach to the starting point again, that is 4. Understood how we need to proceed? Okay, so how can we do it? At each point, what we are doing? We are calculating what? This gas should be greater than cost, right? We are checking this condition. If this is true, then we can start it, right? If we can start, then we are simply applying these things. We are doing what? We are having the gas, we are having the cost, we are calculating the remaining and adding the remaining in the next gas. Correct. So let's say till this point, this condition is not there, right? So at this point, this condition is there. So we will start from here. We will be calculating this formula. That is, what is the formula? That is gas, I think gas. Yes, gas minus cost, right? It will be remaining. Remaining will be this one, right? And we will be adding in the next gas, this remaining part, right? And we will be proceeding further. Let's say after 5, it will come to 5, right? Out of index. So what we can do for this? We can use the modulus. That is I equal to what? I modulus n, right? We will get the index within the 5. This is the brute force approach. So this will be basically for loop under for loop. It will take n square time complexity. Just we are doing the maths. Okay. Now what can be the optimized solution? Optimized solution. And if you want the code for this, I will share in the description what can be the optimized solution for this under O and time complexity. Let's say we are having the gas. What is the gas? 1, 2, 3, 4, 5. What is the cost? It's 3, 4, 5, 1 and 2, right? We are having these two things. Now what was the question? Question is return the starting gas index if we can travel around the circuit and come back to the starting point. Otherwise return -1. Okay, now what is the condition for this return -1. Let's say when we can't reach the same point, I'm saying if total gas or is smaller than total cost, then we can't reach back, we can't complete all of the stations, right? Can I say this? If total gas is smaller than the total cost, that means the cost is greater than the gas. We are not having that much gas which is required. Then we can say we can't reach back, we can't complete all stations. Can I say this? Understood this point? So I can say this: if total gas is smaller than the total cost, right? Then we can say we can't reach the we can't reach back and we can't complete all of the station. We will return false from here only. Okay, this will be the starting point of the code. Now after this, if this is not the condition, then we can say we can reach, right? We can traverse every station. Just we need to find starting point. Okay, so one part is done using this if condition. The second part is we need to find the starting point. What is the starting point? How can we find the starting point? It will be simple. Let's say we have started from this first index. Okay, we will be having condition. We will be having one variable, that is sum will be equal to what? Gas I minus cost I, and we will be adding the remaining in this only, so plus. Okay, or let's say this is remaining gas, correct? So we will be calculating this thing each and every step, right? At each and every step, and whenever this remaining gas is smaller than zero, then we can say the point which we have taken as the starting point is not the starting point. The starting point will be, let's say starting point, next starting point we will be checking for I plus 1, right? Let's say we have started from this one, correct? And what is the cost? Cost is 3. Now it's less than 0, so we can say starting point is 0, 1, 2, 3, 4. Yes, starting point is now this one is the starting point we are taking. Again it will calculate this remaining gas. Again it will be less than 0, right? Again we will be having this as the starting point. Again this will be less than 0. Again we will be having the next I plus 1 as the starting point. At this point it will be greater than 0, right? So we will traverse the next nodes. We will traverse this 5. Okay, so here it will be again greater than 0. So array completed. We can say this point is the starting point. Okay, let's say after this 5 we are having what? One more thing, let's say 6. Okay, now here not 6, let's say 1, right? And let's say cost is 100, right? So when it will come to this point, but this will not be the case. If this is the case, this condition will be true and it will return false. Okay, so what else? Let's say 100 is not there. Something like here is greater value. Okay, and not here. Let's say after, like we are starting with the 4. When it will come to this 5, the remaining value, the remaining gas will be under 0. The cost will be high, let's say. Okay, for an example, this will be high, so this will be 0 again. So the next starting point will be taking the next point, so this one. Got it? So whenever this remaining gas will come to 0, we can say what? The current point is not the starting point, because if we start from this, we can't complete it, right? Because here only it is coming to 0, right, below 0. So how it will go further? The current point should not be the starting point. Try to analyze by yourself once, because from the end we are getting a positive value only, so it will add some positivity, right? It will be making this the remaining gas greater only, correct? So if it's not proceeding to next step at this point, means we can't proceed with the 2 and 3 also. So we will be considering next point after this as the starting point. Let's code it. So 2 variables will be there, that is what? Int total first gas 0, total cost, that will be 0, and what else? For loop, we will be calculating total gas and total cost. I equal to 0, I less than gas dot length I plus plus, then what? Total gas plus equal to gas of I, same with cost plus equal to cost of I, right? Then a condition will be there, if total cost is greater than total gas, we will return false or -1, right? We need to return int value. Great. After that we are having now we know we can reach the same starting point. Now we just need to calculate the starting point. So let's say we are having the pointers int position, right, for the starting point, let's say. Okay, what else? We will be calculating the remaining gas. Okay, it will be 0 initially. After that, for loop int I equal to 0, I less than gas dot length, then I plus plus, right? So what else? What we need to do? Now we will be calculating that cost minus gas, right? Sorry, gas minus cost, and adding the remaining and this remaining gas, right? So remaining gas plus equal to gas of I minus cost of I. Great. We will be getting the remaining sum, the remaining gas. Now if this remaining gas is less than 0, that means cost is higher, we can't reach to the next station. Remaining gas is less than 0, return what? Not return, we need to check for the next position, right? So this remaining gas will be 0 again, remaining gas will be 0 again, and this position, now position will be the next value, right? I plus 1. Great. And that's it. At the end we will be returning this return position. Understood what we are doing? Adding remainings of all stations. So if you see here, we are having this remaining, right? This remaining 6, and we can simply add the remaining of this also, right? This also. That means what is the formula? We are doing what? The gas was what? Gas was, I think, 6 1, right? So what else? -3, and we need to add 6 also. Great. And we are calculating this part. Okay, so we are doing this step in each and every step, right? For this also, for this also. At the end we will be getting the remaining. Okay, and at any point this value is smaller than 0, that means in the negative, right? That means we can't reach to the next station, so return from here only. So again 0, then what else? Starting from next index, because if we start from any of the previous index, we can't reach after this point, correct? Let's run this. Is equal to 0, accepted. Let's submit this. Okay, it's accepted. Understood the logic, guys? Now what is the time complexity for this? We are having simple while loop here and one while loop here. So simple, it's of n and space is constant, right?